So dear student, now today we can discuss about some more properties in the periodic table. So in the last video we have discussed about the periodic classification of elements in the periodic table with respect to its electronic configuration, that is in the form of S block, P block, D block and the F block elements. So one more type of classification we can do in the periodic table, that is metals, non-metals and metalloids. Okay. So we know some of the properties of the metals means. So metals are normally solid, so they are good conductor of electricity and heat. Okay. So in the periodic table, when you observe the extreme left side of the periodic table, it is S block elements. So almost all of they are metals. Okay, and D block elements are also metals. But when you come to the P block elements on this side of the periodic table, right side, so we can find some non-metals and metalloids. So what do you mean by non-metals and metalloids? So metals are, so non-metals are, so they are not good conductor of electricity or heat. Okay. And in case of the non-metals, we can find them in the form of a solid and gases. Okay. So metals are always usually solid. One exception is that is a mercury. Okay. Then metalloid. Metalloid, it is again showing the properties of metals as well as non-metals. So some of the elements are there which show some properties of metals as well as some properties of non-metals. So metal do ಗುಣಧರ್ಮಗಳನ್ನು ತೋರಿಸುತ್ತದೆ, ನಾನ್ ಮೆಟಲ್ do ಗುಣಧರ್ಮಗಳನ್ನು ತೋರಿಸುವುದಕ್ಕೆ ಮೆಟಲಾಯ್ಡ್ಸ್ ಅಂತಾರೆ. ಎಕ್ಸಾಂಪಲ್ ಸಿಲಿಕಾನ್. ಸಿಲಿಕಾನ್ ಇದೆ, arsenic ಇದೆ. Okay. So those are some of the examples for the metalloids. So now let us take here. So the metals, what are the trend of the metals when you move along the period and down the group. So in case of metals, when you take along the period there are 7 periods are there. So when you move from left to right, so what happens to the metallic character? So metallic character decreases as you move in the along the period. For example, if I take here sodium, that is the third period. Sodium, then magnesium. So these are metals. So next when you come to the P block, in D block then bardula. Next you go for P block here. So the next element boron, aluminium. Then comes here aluminium, then silicon, carbon, silicon, nitrogen, phosphorus, sulfur, chlorine, argon. So these two and this one is also metal. This is also metal. Whereas this is a metalloid. Silicon is a metalloid. Whereas these are non-metals. Okay. So means metallic character decreases as you move along the period. So here again you left to the right ಹೋಗ್ತಾ ಹೋಗ್ತೀರಾ. So metallic character decrease ಆಗ್ತಾ ಹೋಗ್ತದೆ. So that is about the along the period. Then what happens to the down the group? When you move down the group, ಕೆಳಗಡೆ ಹೋದಾಗ ಏನಾಗುತ್ತೆ? So metallic character increases. So metallic character increases as you move down the group. So for example, in the first group, so first group elements are Li, Na, K, Rb, Cs, Fr. So if you move down the group, metallic character increase ಆಗ್ತಾ ಹೋಗ್ತದೆ. So here in case of this here, nitrogen, phosphorus, arsenic, antimony, this one. So it is non-metal. This is non-metal. These two are metalloid. So here metallic character increases. Property increase ಆಗ್ತಾ ಹೋಗ್ತದೆ. So this is non-metal. Whereas this is a metal. These two are metalloid. So like this along the period metallic character decreases, down the group of metallic character increases. So this is about the metals, non-metals and metalloids, and in the periodic table we can find out metals also, non-metals also and metalloids. So normally what we consider the S block elements are metals and D block also metals, whereas in case of a P block most of them are non-metals which exist in the form of a solid and gases also. But and metalloids are also there. But when you go down the group, so we can find some metals also. Okay. And extreme left, right side, that is 18 groups are noble gases. Okay. So this is about the metallic properties, or we can classify them in the form of metals, non-metals and metalloids. That is the periodic classification. Now let us go for the next properties, that is called as a periodicity. Periodicity means what? Periods. Periods are now we are having the periods of 40 minutes, 35 minutes, 50 minutes. So after that, once again the another class will start. So periodicity, here also the periodicity means the after certain interval of time the property repeats. So that is how you can take here. So lithium, lithium, beryllium, then boron, and right? And again when it comes sodium, so sodium, the property of these are similar, it repeats. So because of its electronic configuration, similar electronic configuration, so it repeats. So that is known as a periodicity. So periodicity is related to its electronic configuration. Okay. And based on that, we can take some of the properties, that is what happens to the melting point, that is physical point, melting point, boiling point, okay, density. So what happens down the group, as you move down the group, what happens to them? So in the particular order. Similarly, we are having some more properties. Those are atomic radii or ionic radii, then ionization enthalpy, electron gain enthalpy. Okay. So all those properties now we have to study now. Okay. So that is the periodicity and the trends of the periodicity. Especially normally in the exam they will ask what about the atomic radii. What happens along the period as you move along the period atomic radius give reason. ಅದೇ ರೀತಿ ಡೌನ್ ದ ಗ್ರೂಪ್ ಹೋದಾಗ ಏನಾಗುತ್ತೆ ಅಟಾಮಿಕ್ ರೇಡಿಯೈ. ಓಕೆ, ಸಿಮಿಲರ್ಲಿ ಅಯೋನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಏನಾಗುತ್ತೆ, ಎಲೆಕ್ಟ್ರಾನ್ ಗೇನ್ ಎಂಥಾಲ್ಪಿ ಏನಾಗುತ್ತೆ, ಆಲ್ ದೋಸ್ ಥಿಂಗ್ಸ್ ಆರ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಡಿಸ್ಕಸ್ ನೌ. ಓಕೆ, so now let us take up atomic radius. See, we know atom is very very small. So atom ne kanne ki kanudilla. Then how to measure its radius? Okay, atomic radius or metallic radius. So we know atom itself is a very very small. Its radius is we can't measure directly. So normally the method is used is a X-ray diffraction or a spectroscopy method to identify that or to calculate the radius. But so here the method is used. So it is nothing but the half of the distance between the two atoms, which is covalently bonded. Suppose this is one atom. It is a nucleus and it's an atom. This is another atom, means the same atom. Okay. So they are covalently bonded. You know, covalent bond means what? It is a sharing of electron. So they are sharing the electron and they form a molecule. Now we can measure this distance because it is a little larger, and the distance of this divided by 2, half of the distance between the two covalently bonded, single bond, not a double bond. Okay, single bond covalent bonded, half of the distance is known as the atomic radius. Okay, so electrons are moving around the nucleus, and we can't judge where the exactly the effect of electrons. So therefore, here half of the distance between the two nuclei, which is covalently bonded, that is considered as a atomic radius. For example, if I consider this is one chlorine atom, this is another chlorine atom. So they are covalently bonded to Cl2. That's a chlorine molecule. This is the molecule, this is the atom. See the difference. This is Cl, this is Cl. This Cl2 and ಎರಡು chlorine metabolic structure. That is covalently bonded. Okay. So now here this measurement is found to be 198 picometer. This is a chlorine molecule. So therefore, what is the radius of this? That is nothing but 198 divided by 2 is equal to 99 picometer. Half of the distance between the two singly bonded atoms. Similarly, okay, so that is the atomic radius of a chlorine is 99 picometer. Followed here how to find out the atomic radius. Next, how the atomic radius changes along the period and down the road. So normally asked question, very important questions. Normally they ask how the atomic radius increase along the period, variation of atomic radius along the period and down the road, as well as the mentioned reason also. So along the period, from left to right. So sodium, magnesium, then aluminium, silicon, like that. Along the period, what happens to the atomic radius? It decreases. Along the period, atomic radius decreases. So this is the first atom radius on the extreme left side. Okay. So you have to remember this diagram at least so that you can indicate the size slowly decreases. Atomic radius decreases along the period. So, ಈಗ ಕ್ವಶನ್ ಕೇಳಿದ್ರೆ how it varies ಇಷ್ಟೇ ಬರ್ಸಕ್ along the period decreases. ಯಾಕೆ ಅಂತ ರೀಸನ್ ಕೇಳಿದ್ರೆ ರೀಸನ್ ಬರೀಬೇಕು. ರೀಸನ್ ಕೇಳಿಲ್ಲ ಅಂದ್ರೆ ಬರೆಯುವಂತ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. Along the period atomic radius decreases. ಯಾಕೆ ಕಡಿಮೆ ಆಗ್ತದೆ? ಡಿಕ್ರೀಸ್ ಯಾಕೆ ಆಗ್ತದೆ? As we move along the period, atomic number increase ಆಗ್ತಾ ಹೋಗ್ತದೆ. Atomic number increase ಆಗಿದೆ ಅಂದ್ರೆ ಏನಂತ? Electrons increase ಆಗಿದೆ. So electron increasing, but electrons are entering into the same shell. So electrons are entering into the same shell. ಅದೇ ಶೆಲ್ ನಲ್ಲಿ ಎಂಟರ್ ಆಗೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ? So there is a size will not increase. And also one more very important reason is a nuclear charge. Nuclear charge increases. Nuclear charge ಅಂದ್ರೆ ಏನು? ನ್ಯೂಕ್ಲಿಯಸ್ ನಲ್ಲಿ, ನ್ಯೂಕ್ಲಿಯಸ್ ಒಳಗಡೆ ಇರ್ತದೆ, ಇಲೆಕ್ಟ್ರಾನ್ ಹೊರಗಡೆ ಸುತ್ತಾ ಇರುತ್ತೆ. ಸೊ ನ್ಯೂಕ್ಲಿಯಸ್ ಚಾರ್ಜ್ ಏನಾಗುತ್ತೆ? ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ನ್ಯೂಕ್ಲಿಯಸ್ ನಲ್ಲಿ ಪ್ರೋಟಾನ್ ಮತ್ತು ನ್ಯೂಟ್ರಾನ್ ಇರ್ತದೆ. ಪ್ರೋಟಾನ್ ಹೆಚ್ಚಿಗೆ ಆಗುತ್ತೆ. ಆಸ್ ದ ನಂಬರ್ ಆಫ್ ಪ್ರೋಟಾನ್ ಇನ್ಕ್ರೀಸಸ್, ನ್ಯೂಕ್ಲಿಯರ್ ಚಾರ್ಜ್ ಇನ್ಕ್ರೀಸಸ್. ಅವಾಗ ಏನಾಗ್ತದೆ? ಅಟ್ರಾಕ್ಷನ್ ಬಹಳ ಆಗುತ್ತೆ. ಸೊ ಮೋರ್ ಅಂಡ್ ಮೋರ್ ದೇ ಆರ್ ಅಟ್ರಾಕ್ಟೆಡ್ ಟುವರ್ಡ್ಸ್ ದ ನ್ಯೂಕ್ಲಿಯಸ್. ಆಟೋಮೆಟಿಕ್ಲಿ ಸೈಜ್ ಕಡಿಮೆ ಆಗಲಾಗ್ತದೆ. So therefore this we can see it is decreases along the period. Electrons are entering into the same shell ನಲ್ಲಿ ಹೋಗ್ತಾ ಇದೆ. ಸೇಮ್ ಶೆಲ್ ನಲ್ಲಿ ಎಂಟರ್ ಆಗೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ? ಅಲ್ಲಿ ಹೊಸ ಶೆಲ್ ಹೋದ್ರಷ್ಟು ಹೆಚ್ಚಿಗೆ ಆಗುತ್ತೆ. ಸೇಮ್ ಶೆಲ್ ನಲ್ಲಿ ಹೋದ್ರಿಂದ ಅಷ್ಟೊಂದು ವೇರಿಯೇಷನ್ ಆಗುದಿಲ್ಲ, ಹೆಚ್ಚಿಗೆ ಆಗುತ್ತೆ. ಅದ್ರ ಬದಲ ಏನಾಗುತ್ತೆ, ನ್ಯೂಕ್ಲಿಯರ್ ಚಾರ್ಜ್ ಹೆಚ್ಚಿಗೆ ಆಗುತ್ತಾ, ದೇ ಆರ್ ಅಟ್ರಾಕ್ಟೆಡ್ ಟುವರ್ಡ್ಸ್ ದ ನ್ಯೂಕ್ಲಿಯಸ್, ಅದಕ್ಕಾಗಿ ಸೈಜ್ ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗ್ತದೆ. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ಅಲಾಂಗ್ ದ ಪೀರಿಯಡ್. ನೆಕ್ಸ್ಟ್ ಡೌನ್ ದ ಗ್ರೂಪ್. ಡೌನ್ ದ ಗ್ರೂಪ್ ಅಂದ್ರೆ ನಾವು ಕೆಳಗಡೆ ಬರ್ತಾ ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ, ಸೊ ದಿಸ್ ಇಸ್ ನೌ ಅಲಾಂಗ್ ದ ಪೀರಿಯಡ್. ಡೌನ್ ದ ಗ್ರೂಪ್, ಹಿಯರ್ ಇಟ್ ಇನ್ಕ್ರೀಸಸ್. ಇನ್ಕ್ರೀಸಸ್ ಅಂದ್ರೆ ಹೆಚ್ಚಿಗೆ ಆಗುತ್ತೆ. ಹೌ ಇಟ್ ಇನ್ಕ್ರೀಸಸ್, ವೈ ಇಟ್ ಇನ್ಕ್ರೀಸಸ್, ಯಾಕೆ ಹೆಚ್ಚಿಗೆ ಆಗುತ್ತೆ, ಇನ್ಕ್ರೀಸ್ ಯಾಕೆ ಆಗ್ತದೆ? ಬಿಕಾಸ್ ಡೌನ್ ದ ಗ್ರೂಪ್ ಹೋದಾಗ ಏನಾಗುತ್ತೆ, ಶೆಲ್ ಹೆಚ್ಚಿಗೆ ಆಗ್ತಾ ಹೋಗ್ತದೆ. ಕೆ ಶೆಲ್, ಎಲ್ ಶೆಲ್, ಎಂ ಶೆಲ್, ಎನ್ ಶೆಲ್. ಸೊ ಶೆಲ್ ಹೆಚ್ಚಿಗೆ ಆದಾಗ ಏನಾಗುತ್ತೆ, ಸೈಜ್ ದೊಡ್ಡದಾಗುತ್ತೆ. ಸೈಜ್ ದೊಡ್ಡದಾದ್ರೆ ಏನಾಗುತ್ತೆ, atomic radius increases. Okay, because atomic number also increases as you go down the group, as well as the number of shell increases, hence its size increases. So down the group ಏನಾಗುತ್ತೆ, ಇನ್ನು ಸ್ವಲ್ಪ ದೊಡ್ಡದಾಗ್ತಾ ಹೋಗ್ತದೆ. So like that, it increases down the group. Because why? That is a number of shell increases. Number of shell increases. As the shell increases, so electron will enter to the next shell. Next shell size ಹೆಚ್ಚಿಗೆ ಆಗುತ್ತೆ. Size ಹೆಚ್ಚಿಗೆ ಆದ್ರೆ radius ಹೆಚ್ಚಿಗೆ ಆಗುತ್ತೆ. Okay. So this is how to explain that. Normally why ಅಂತ ಕೇಳೋದಿಲ್ಲ give result, but you have to remember this along the period and down the group. ಒಂದು ಡಿಕ್ರೀಸ್ ಆದರೆ ಇದು ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಇಸ್ ದಿಸ್, along the period atomic radius ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಉಳಿದಿದ್ದು ನಾವು ಮುಂದೆಲ್ಲ ಸ್ಟಡಿ ಮಾಡೋದಿಲ್ಲ. ಅಯೋನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಇದೆ, ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಇದೆ, ಎಲೆಕ್ಟ್ರಾನ್ ಗೇನ್ ಎಂಥಾಲ್ಪಿ ಇದೆ, ಅದೆಲ್ಲ ಇದರಲ್ಲಿ ಉಲ್ಟಾ ಆಗುತ್ತೆ. ಸರಿ, ಸೊ ಡೌನ್ ದ ಗ್ರೂಪ್ atomic radius increase ಆಗುತ್ತೆ. ಓಕೆ, ಉಳಿದಿದ್ದೆಲ್ಲ ಕಡಿಮೆ ಆಗುತ್ತೆ. So this is about the along the period and down the group of atomic radius. Now one more comes here, ionic radius. Ionic radius. Ions ಅಂದ್ರೆ ಎರಡು ನಮೂನೆ ions ಇದಾವೆ. ಒಂದು ಕೇಟಾಯಾನ್, ಇನ್ನೊಂದು anion. ಕೇಟಾಯಾನ್ ಇಸ್ ಪಾಸಿಟಿವ್ ಇರ್ತದೆ, anion ನೆಗೆಟಿವ್. ಕೇಟಾಯಾನ್ ಯಾವಾಗ ಆಗುತ್ತೆ, ನ್ಯೂಟ್ರಲ್ ಆಟಮ್ ಇದೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಫ್ ಐ ಟೇಕ್ ಸೋಡಿಯಂ, ಸೋಡಿಯಂ ಇಸ್ ಅ ನ್ಯೂಟ್ರಲ್, ಇದಕ್ಕೆ ಏನು ಚಾರ್ಜ್ ಇಲ್ಲ, ನ್ಯೂಟ್ರಲ್. ಇದೇನಾಗುತ್ತೆ, Na plus ಆಗುತ್ತೆ, that is a cation. How it becomes a cation ಹೇಗಾಗುತ್ತೆ, ಅದು ಪ್ಲಸ್ ಯಾಕೆ ಆಯ್ತದು, ಒಂದು ಇಲೆಕ್ಟ್ರಾನ್ ಕೊಡ್ತು ಬೈ ಲಾಸ್ ಆಫ್ ಇಲೆಕ್ಟ್ರಾನ್. ಸೊ ಲಾಸ್ ಆಫ್ ಇಲೆಕ್ಟ್ರಾನ್ ಅಂದ್ರೆ ಏನಾಯ್ತು, ನಂಬರ್ ಆಫ್ ಇಲೆಕ್ಟ್ರಾನ್ಸ್ ಕಡಿಮೆ ಆಯ್ತು, ಪ್ರೋಟಾನ್ ಏನಾಗಿರೋದು, ಸೊ ನ್ಯೂಕ್ಲಿಯರ್ ಚಾರ್ಜ್ ಇನ್ಕ್ರೀಸ್. ಸೊ ಇಲೆಕ್ಟ್ರಾನ್ ಕೊಟ್ಟಿದ್ರಿಂದ ಸೈಜ್ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಸೊ ಫಾರ್ ಅ ಕ್ಯಾಟಯಾನ್, ಸೊ ದ ಸೈಜ್ ಕಂಪೇರ್ ಟು ದಿಸ್, okay, so cation is already smaller in size, whereas the anion if I take on Cl is ಏನಾಗುತ್ತೆ, Cl minus. So this is the neutral, this is the anion. Anion minus ಗೆ ಏನು ಮಾಡ್ತದೆ, by gain of one electron ತಗೊಳ್ಳೋದು, gain of electron ತಗೊಳ್ತಂದ್ರೆ ಏನಾಯ್ತು, ಆಲ್ರೆಡಿ ಇಲೆಕ್ಟ್ರಾನ್ ಇರ್ತದೆ ಅಲ್ಲಿ, ಮತ್ತೊಂದು ಇಲೆಕ್ಟ್ರಾನ್ ಬಂದಾಗ ಏನಾಗುತ್ತೆ, we know that is a like charge repel each other, ಸಜಾತಿಯ ಧ್ರುವಗಳು ವಿಕರ್ಷಿಸುತ್ತವೆ. ಸೊ ಆಲ್ರೆಡಿ ಇಲೆಕ್ಟ್ರಾನ್ ಟೇಕ್ ಕೇರ್. So this is the nucleus at the center which is having positive charge. This is the one shell, K shell 2 electrons, L shell, so 1, 2, 3, 4, 5, 6, 7, 8. So chlorine ಇನ್ನೊಂದು ಬರ್ತದೆ. Okay, imagine okay, one more cell, 1, 2, 3, 4, 5, 6. If I want to add one more electron will happen. Again, it is to come here. So already electron ಇದೆ, it will repel each other. ಏನಾಗುತ್ತೆ, ರಿಪೆಲ್ ಆದಾಗ ಏನಾಗುತ್ತೆ, ಇದು ಸೈಜು ಸ್ವಲ್ಪ ಇದು ದೊಡ್ಡದಾಗುತ್ತೆ. ಸೊ ಇಟ್ ವಿಲ್ ಮೂವ್ ಅವೇ. ಸೊ ಸೈಜ್ ಹೆಚ್ಚಾಗುತ್ತೆ. ಸೊ therefore in case of an ion, size or radius increases, whereas the cation decreases because it gives one electron, whereas here it takes electron. So that is the difference between the cation and anion compared to the neutral. So ಇದರದ್ದು ಸೈಜ್ ಕಡಿಮೆ, ಇದರ ಸೈಜ್ ಜಾಸ್ತಿ. ಇಲ್ಲಿ ಉಲ್ಟಾ, anion size is more than the neutral. So this is about the atomic and ionic radius. Okay. Okay, right. If I take here an example of sodium atomic radius, any atomic radius equal to 186, whereas Na plus ionic radius is 95. Picometer. Whereas chlorine this chlorine is having a radius is 99, whereas Cl 181, it increases. So that is the reason is because here it is a gain of electron will repel and the size increases, where here loss of electron size kadme. Okay, so nuclear charge increases, it is attracted towards the nucleus, so therefore size decreases. So this is about the atomic radius and ionic radius. So next periodicity or trend is ionization enthalpy. Okay.